እንዴት ናችሁ የተከበራችሁ የዩቲዩብ ቻናል ቤተሰቦች? በዚህ ቪዲዮ ትናንት እየሰራው የቀረው የማቴማቲካል አናሊሲስ ፓርት እና ዲቴል ኤክስፕሌኔሽን የሚጠይቁ ጥያቄዎችን ለነገ ፈተና እንዲደርስ አድርጌ አቀርባለሁኝ። ጥያቄዎቹን ቪዲዮን እስከ መጨረሻ እንድታዩ እላለሁኝ። ለቻናሉ አዲስ ከሆናችሁ ቻናል ሰብስክራይብ አድርጉ። ቻናል ላይ ኦር ቪዲዮ ላይ ኮሜንት ጻፉበት። ቪዲዮን ለጓደኞቻችሁ ሼር አድርጉ። ፕላስ ቴሌግራም ግሩፓችሁ ላይ ወደ 1550 አካባቢ ፓርቲሲፓንት ኦር ፎሎወር አለ። ግን እስካሁን ድረስ ሰብስክራይብ ያደረጋችሁ በጣም ጥቂት ናችሁ። ይሄን ቻናል ሰብስክራይብ እንድታደርጉ ይላለሁኝ። ቀጥታ ወደ ጥያቄዎቹ ገባለሁ። የመጀመሪያ ጥያቄ the following figure illustrates a three pipe in series and for the three pipe arranged shown in the figure the total flow rate and the head of the system are, here we have three pipes connected in series and we are asked to calculate the total flow rate and the head of the system. So A, Q total, which is Q1 plus Q2 plus Q3, and H total, which is H1 plus H1, which is equal with H2, which is H3. B, Q total, which is equal with Q1, which is equal with Q2, and equal with Q3, and H total is equal with H1, which is equal with H2, equals to H3. C, Q total, which is equal with Q1, equals Q2, equals Q3, and H total, which is H1 plus H2 plus H3, and D, none of the above. So from this, which equation shows or which formula shows the total flow rate and the head of the system? So to know this, let me describe, or to answer this, it needs some description, and we have to know what the formula to calculate total flow rate and head of the system when these pipes are connected in series. So let me describe the part. So here, when pipes are arranged in series, the flow rate through each pipe remains the same. So the flow rate, when these pipes are connected in series, the flow rate is the same. That means the overall flow rate or the total flow rate is equal with the flow rate at each or at individual pipes. So here, when pipes are arranged in series, the flow rate through each pipe remains the same, and while the head loss or pressure drop accumulates across each pipe. And to calculate the total flow rate and head of the system for the three pipes arranged in series, we can use the following formula here. When the total flow rate or Q total is calculated by using this formula, since the pipes are arranged in series or connected in series, the total flow rate through the system is the same as the flow rate through each individual pipes. And therefore, the total flow rate or Q total is simply the flow rate through any one of the pipes. It may be the flow rate at Q1 or pipe 1 or pipe 2 or pipe 3. Therefore, this Q total is equal when these pipes are arranged or connected in series. Therefore, the first we have to see this Q total, which is equal with Q1 or equal with Q2 or equal with Q3 from the given alternative. The next, how to calculate this, the head loss. So the total head loss, which is through the system, is the sum of the head losses across each individual pipes when the pipes are connected in series. And here the total loss or the head loss, which is calculated as H total, which is H1 plus H2 plus H3, where this H1, H2, and H3 are the head losses across each pipe. Therefore, finally, we have to see the formula, the equation with this Q total, which is equal to the individual Q's, and this H total is equal to the summation of individual heads. So the correct answer with this is here. The correct answer is here. Q total, which is equal to Q1, Q2 or Q3, and H total is equal with H1 plus H2 plus H3. Therefore, the correct answer for this question is C. The correct answer for this question is choice C. So this choice C is correct answer. So if the pipes are connected in series, we can calculate, or the formula to calculate total flow rate is, or the total flow rate equal with the individual flow rate, and the total head or the total head loss, which is equal with the summation of individual head loss. Question number two. Here we have given question number 2. We have given that from the illustrated experimental result in figure below that support to check the encountered error systematically, which statement describe the result correctly? A. Result A is inaccurate and precise. B. Result B is inaccurate and imprecise. C. Result A is accurate and imprecise. D. Result B is inaccurate and precise. So from this, which one describes this the measurement result or experimental measurement result? So to answer this also, we have to know what does accuracy and precision mean during the measurement. And let me explain them. In experimental analysis, this accuracy and precision are two important concepts in the context of measurement. And this when we say accuracy, this accuracy refers to how close a measured value is to the true or accepted value of the quantity being measured. So we have a target, or we have the true value. We have true value or the target, and when this measured value is more close to that of the true value, that we call it this accuracy. And when we say this precision refers to the degree of repeatability or consistency of measurement. It shows this the consistency of the measurement, how much this measured value is consistent or keeps their consistency. So that means it indicates how well individual measurements agree with each other. So how much this individual measurements agree with each other, or how much this individual measurement is close to each other. So this is what the precision. And when we say this accuracy, high accuracy implies that the measured value are very close to the true value, while low accuracy indicates a significant deviation from the true value. And when we come to this high precision implies that the measured values cluster closely together. And when we say this low precision, it indicates greater variability or scatter in measured values. So this is what the accuracy and the precision mean. And for example, when we say this low accuracy, and when we say this here we have target. This is the target for our measurement, and here there is measurement is around this, and this shows us low accuracy and low precision because our target is here, and the values are the measurements are far from each other, as well as they are far from the center or our target. So this is low accuracy and low precision. When we come to this low accuracy and high precision, when we say precision, they are how much the measured value close to each other. So the values are close to each other or close with each other, but they are far from the center or the target that we want. Therefore, this shows the low accuracy and high precision. And the other, when we say high accuracy and low precision, it means that here we have the center, or here we have the target, and the measured values are near to the target, but they are far from each other. Here one measurement here, the other here, the other here. So the measurements are far from each other, but they are around the center or around the target. So this shows high accuracy and low precision. And the next, high accuracy and high precision means here all the points are at the center or at the target, as well as they are close to each other, or the measurements are close to each other. Therefore, this type of measurement is high accurate and high precise. So when we come to our specific question, here we have given that this is the target that we have or we want to measure, and the values here we have 5 measurements, and the values are around the center or around the target at A. But at B, they are far from the target. The target is here, but the measured values are around here. So this result A shows that the values or the measurement is accurate, but the values or the relationship between each measurement is imprecise because they are far from each other. And in B, here the measurement is far from the center or the target, as well as the measured values itself or themselves are far from each other. So result A is accurate and imprecise, but result B is inaccurate and imprecise. Result B is inaccurate as well as imprecise. So ይህን እንደዚህ ካልኩ በኋላ በጥያቄው ላይ በቾይስ ላይ አሁንም በትናንትም የሆነ ቪዲዮ ላይ ይቻለው ችግር እንዳለበት ነው ያየሁት። ምክንያቱም እንደዚህ የሚያሳይ ሁለት ጥያቄ ሁለት ስላለ ማለት ነው። So when we come to the question, here result A is inaccurate and precise. Result A is inaccurate and precise. This is wrong because result A is accurate. Result B is inaccurate and imprecise. This is right because this result B is inaccurate as well as imprecise. Result A is accurate and imprecise. Result A is accurate and imprecise. This is also right. This is also right. And result B is inaccurate and precise. This is wrong because result B is not precise. This is not precise because the measured values are far from each other. So the correct answer for this question is what questionable ጥያቄ የሚያስነሳ ነው but በትክክል መምረጥ የምንችለው ከሁለቱ አንዱን ከመረጥን most probably 50-50 ይሆናል ማለት ነው። ስለዚህ አሁን በትክክል ደግሞ የትኛውን ብንመርጥ ነው ከዚህ ከሁለቱ የሚሻለን ለኛ ከሁለቱ የትኛውን ብንመርጥ ነው የሚሻለን ይሄን ብንመርጥ የተሻለ ይሆነልናል ማለት ነው። So this is the question or the answer for this question. ሁለቱም መምረጥ ይቻላል። ሁለቱም ላይ ያው ትክክለኛውን ኤክስፐሪመንታል ሪዛልቱን ያሳያል ማለት ነው። ቀጣይ ጥያቄ question 3 identify which of the following statements is true about the result of the engineering stress strain behavior for iron at different temperature shown in this figure. So here we have the material iron which shows the stress strain diagram for the material iron in different temperature 25 degrees Celsius, minus 100 degrees Celsius and minus 200 degrees Celsius. So which one is true about this graph? A, the plastic deformation of the material is affected severely when temperature decline. That means the plastic deformation of iron is affected severely when temperature decline. B, rate of fracture after yielding stress is affected severely in very cold environment. C, the linear elastic behavior of the material or the iron is affected to low degree due to temperature variation. D, fracture can delay along or long for material which is exposed to temperature close to negative 200 degrees Celsius. So from this, which one is true or which one shows the correct for this engineering stress strain diagram for iron? So let me discuss each choices. In A, each size, the plastic deformation of iron is affected severely when temperature declines. This statement suggests that the plastic deformation of iron is severely affected by decreasing temperature. But however, this typically the opposite is true for many materials, including this iron, the given iron. That means at low temperature, materials like iron tend to become stronger and more resistant to plastic deformation due to reduced thermal energy facilitating dislocation movement. And therefore, this plastic deformation is less affected by decreasing temperature rather than severely affected. Therefore, due to this is incorrect. This is incorrect about that graph. The other is rate of fracture of iron after yielding stress is affected severely in very cold environment. So this statement suggests that the rate of fracture of iron after reaching its yielding stress is severely affected in very cold environment. So let me show you by breaking this the statement is when we say this brittleness at low temperature, this iron like many other metals, it tends to become more brittle at low temperature, and as this temperature decrease, the moment of dislocation within the metal lattice is restricted due to thermal energy, and this restriction can lead to decrease in ductility and an increase in brittlity. So in yielding and fracture, when a material like iron is subjected to stress, it undergoes deformation, and initially the material deforms elastically until it reaches its yield strength, and beyond which this plastic deformation occurs. And at very low temperature, the ductility of the material, like this, the iron is decreased. That means it is less able to undergo plastic deformation before fracturing. So, in general, in third point, we have effect on fracture rate in a very cold environment. Once the yield strength of iron is surpassed and plastic deformation begins, the reduced ductility means that the material is more prone to fracture rather than undergoing significant plastic deformation before fracturing. So this can result in higher rate of fracture once yielding strength is reached compared to when the material is at high temperature. And fourthly, when we see the material property and environment, it is important to note that the specific temperature at which material become brittle can vary depending on the factors such as the composition of the material. So here I go to this material properties and the environment, that we have to notice that this specific temperature at which a material become brittle can vary depending on the factors such as this composition of the material, its microstructure, and the rate of loading. And however, this in general, extremely low temperature can significantly affect the fracture behavior of materials like iron, making them more prone to this brittle fracture. Therefore, when I summarize this, in summary, this statement B accurately highlights the rate of fracture of iron after reaching its yield strength can be severely affected in very cold environment due to the increased brittleness of the material at low temperature. And when I go to this C, the linear elastic behavior of the iron is affected to a low degree due to temperature variation. While this temperature can influence the material's property of iron, the linear elastic behavior, such as this elastic modulus of iron, is generally not significantly affected by the temperature variation within given range. That means we have the temperature given as from minus 200 degrees Celsius to 25 degrees Celsius. So this iron is typically exhibit this relatively constant elastic modulus over a wide temperature range, especially in the range specified in this the given question. That means from this to this. And therefore, this statement is not accurate. This is not accurate, as it suggests a low degree of influence on elastic behavior, which is typically minimal. And then D, here fracture can delay long for iron, which is exposed to temperature close to negative 200 degrees Celsius. This statement implies that the exposure to temperature close to minus 200 can delay fracture for iron. However, this extremely low temperature often make material like iron more brittle rather than delaying its fracture. And at temperature which is close to this 200 degrees Celsius, iron is likely to become exceedingly brittle, which increase the risk of fracture rather than delaying it. Therefore, this statement is also not accurate. And when I summarize this, is in summary, while temperature can indeed influence the mechanical property of material like iron, the statement presented in option A, C, and D do not accurately reflect the typical behavior of iron with respect to temperature variation within the given range. And therefore, this based on the typical behavior of material like iron, the most accurate statement among the option provided for us is this B, rate of fracture of iron after yielding strength is affected severely in very cold environment. So this is the correct answer for this question. So the correct answer is B. This B is for this graph. B is correct answer. So from the discussions that I have provided for you. The next question, for a given power transmission, see figure below. For in this figure, designed with the sliding gear arrangement, what will be the speed ratio of output to input when gear 10-11 slides to the left to engage with 7-11, while gear 6 and 10 and gear 4 and 5 are disengaged and others remain in their position. So እዚህ ጋር የተጠየቅነው አሁን እንደዚህ አይነት ጊር ተሰጥቶናል። ጊር 6 እና 10 እዚህ ጋር ጊር 10 አለ፣ ጊር 6 አለ። እነዚህ ዲስኢንጌጅ ይሆናሉ። ጊር 4 እና 5 ዲስኢንጌጅ ቢሆኑ እና ጊር 7 ከጊር 11 ጋር ጊር 7 ከጊር 11 ጋር ኮኔክት ቢሆን that means ጊር 11 ይሄ ነው፣ ጊር 7 ይሄ ነው። ይሄ ወደዚህ shift ቢያደርግ the speed ratio of output to input or n output to n input ስንት ይሆናል ነው። So A 0.87, B 2.77, C 1.14, D 0.77. ስለዚህ እንደዚህ አይነት ጥያቄዎችን ለመስራት አሁን ይሄ የሚያሻማ ጥያቄ ነው። ሲሰሩ ሜቢ እንዳትሸወዱ መጀመሪያ ጥያቄውን በትክክል ማየት መቻል አለብን። በዚሁ እንዳለ ይሄ አሲቲስ ከሰራን እንሸወዳለን ማለት ነው። ምክንያቱም እዚህ ጋር ዲስኢንጌጅ የሚደረጉ ኦር የሚሆኑ ፓርቶች አሉ። ፎር ኤግዛምፕል ጊር 6 እና ጊር 10 ኢንጌጅ ናቸው በዚህ ኬስ በት እኛ በተጠየቅነው ላይ ግን እነኚህ ጊር 6 እና 10 ዲስኢንጌጅ ከሆኑ በኋላ ነው የምንሰራው። ጊር 5 እና ጊር 4 እዚህ ጋር ኢንጌጅድ ናቸው በት በተጠየቅነው ላይ እነኚህንም ዲስኢንጌጅ አድርገን ነው የምንሰራው ማለት ነው። ሶ ይሄን ዲስኢንጌጅ ስናደርግ ይሄ ወደዚህ shift ያደርጋል 10 ወደ 7 10 7 ጋር ኮኔክትድ ሆኖ እዚህ ጋር ኮኔክት የሚሆኑት ሁለት ፓርት ብቻ ይሆናል ማለት ነው። ይሄ 7 ከ10 ጋር 11 ጋር ኮኔክት ይሆናል። 2 ከ8 ጋር አስቲስ ኮኔክት ሆኖ ይቀመጣል ማለት ነው። ሶ እንደዚህ አይነት ስራዎች እንደዚህ አይነት አናሊሲስ ለመስራት ማወቅ አለብን። አንደኛ ኢንፑት የቱ ጋር ነው፣ አውትፑት የትኛው ነው የሚለውን ማወቅ መቻል አለብን። ሌላ ደግሞ ማወቅ ያለብን የስፒድ ሬሽዮ ከዲያሜትር ኦፍ ጊር ፕላስ ከቲዝ ናምበር ኦፍ ጊር ያለው ሪሌሽንሺፕ በትክክል ማወቅ መቻል አለብን። ሶ ሂር ዊ ሃቭ ጊቨን ኢንፎርሜሽን ጊር 10 እና 11 ስላይድ ያደርጋሉ። ጊር 7 and 11 engaged, gear 6 and 10 disengaged, gear 4 and 5 disengaged also. And we are asked to calculate gear speed ratio of output to input. That means n output, the ratio of n output to n input, which is unknown. So to calculate the speed ratio, so this the speed ratio in compound gear train, which is similar with the given that we have, is this, which is when multiple gears are connected or interconnected, the input and output gear can be identified based on the direction of the rotation and the desired output related to the input. So እዚህ ጋር ማወቅ አለብን የትኛው ጊር ኢንፑት ፓርት ላይ ነው ያለው፣ የትኛው አውትፑት ላይ ያለው። ይሄን በትክክል መጀመሪያ ዲፈረንሺየት ማድረግ መቻል አለብን ማለት ነው። ሶ ኢንፑት እና አውትፑት ካወቅን በኋላ ነው ይሄን ስራ መስራት የምንችለው። ሶ ከዛ በኋላ ደግሞ ማወቅ ያለብን ሌላ the relationship between speed, diameter and teeth number of gear. So የጊር ስፒድ diameter of the gear plus the teeth number of the gear ያለው ሪሌሽንሺፓቸው ምን አይነት ነው፣ ይሄን በትክክል ማወቅ መቻል አለብን። ይሄን ካላወቅን ለመስራት ያስቸግረናል፣ ግን ካወቅን በቀላሉ መስራት እንችላለን ማለት ነው። So here we have the relationship between this speed, the diameter as well as the teeth number for gear. So relationshipቸው እንዴት ነው? n2 n1, that means this the number of teeth and the diameter of the gear is directly proportional, but they are inversely proportional to that of the speed. So n2 over n1 times n4 over n3, which is equal with d1 over d2 times d3 over d4, which is equal with t1 over t2 times t3 over t4. So relationshipቸው በዚህ መልክ ነው የምንሰራው። So diameter እና teeth number directly proportional ናቸው, but this speed እና this diameter teeth number inversely proportional ይሆናሉ ማለት ነው። Therefore የተጠየቅነው speed of this output, the ratio of output to input speed ነው። So which is output የትኛው ነው በተሰጠን ጊር ላይ እዚህ ጋር በጊሩ ላይ በቀላሉ ማየት እንጂ output ማለት የትኛው ነው? output በዚህ ኬዝ እዚህ ጋር ኢንፑት ይገባል፣ ይሄ output ይሆናል። So output ጊር ማለት እዚች ላይ የትኛው ነው? እዚህ ጋር output ጊር 11 output ነው። እዚህ ጋር ደግሞ 8 እዚህ ጋር 2 ኢንፑት ነው። በሁለት እንደዚህ ይገባል፣ ዘን 8 ላይ አውትፑት ይወጣል ማለት ነው። ዘን ይሄ 8 ላይ ያለው በዚህ ሻፍት ላይ ያለው ስፒድ ከዚህ ጋር በዚህ 7ም ከዚህ ከ8 ጋር ኢኩል ስለሆነ በ7 ላይ ኢንፑት ይገባል። ዘን 11 ወደዚህ ኢንጌጅ ሲሆን አውትፑት በ11ኛው ጊር ይወጣል ማለት ነው። ስለዚህ here we have n8 over n2, that means n8 here we have n8 output to this n2 input times n11 means this one, n11 output here, n11 over n7 which is input equal with this as we know this teeth number and this speed is inversely proportional. ስለዚህ inversely proportional ስለሆነ ይሄን n2 እዚህ ጋር ዲኖሚኔተር ነው፣ n2 እዚህ ጋር n8 over n2 የነበረውን t2 over t8 እናደርጋለን ማለት ነው። ታይምስ እዚህ ጋር n7 over n11 የነበረውን t7 n11 over n7 የነበረውን t7 over t11 ብለን በቀላሉ ፎርሙላውን ዴቨሎፕ እናደርጋለን ማለት ነው። እንደዚህ ካደረግን በኋላ this t2 ማለት ተሰጥቶናል 15 ነው የተሰጠን፣ እዚህ ጋር t8 ማለት ደግሞ 21 እዚህ ጋር ተሰጥቶናል፣ t7 ማለት 27 እዚህ ጋር ተሰጥቶናል፣ t11 ማለት 22 እዚህ ጋር ተሰጥቶናል ማለት ነው። ሶ ይሄን ማልቲፕላይ ማድረግ ነው ቀጣይ ስቴፕ። ማልቲፕላይ ስናደርግ ይሄ ፓርት 15 over 21 0.71 ይመጣል፣ 27 over 22 ደግሞ 1.22 ይመጣል። ሶ ይሄን ስናባዛ 0.87 እናገኛለን ማለት ነው። ሶ ይሄን ከዚህ ቫልዩ ጋር ያለው የትኛው ነው ኮሬክት አንሰር? ኦፕሽን ኤ ኮሬክት አንሰር ይሆናል ማለት ነው። Therefore, for this question, option A is correct answer. The speed ratio of output to input when this with this information is 0.87 ይሆናል። ኦኬ ሌላ ጥያቄ ይሄን በቀላሉ የምንመልሰው ጥያቄ ነው። ያው ኤክስፕላኔሽን ስላለ ኤክስፕላኔሽን ላይ አልገባም። If we want to manufacture a machine part by heating a metal or alloy above its melting point and pouring the liquid or metal or the alloy in a cavity approximately of some shape and size as the machine part, which method of this manufacturing should be followed? A. Extrusion, B. Rolling, C. Forging, D. Casting. Therefore, ይሄን ያው እያንዳንዱን ዲስከስ አድርጌያለሁ። what does extrusion mean? extrusion ማለት ነው። ሮሊንግ ማለት ምን ማለት ነው? ከዚህ ማየት ትችላላችሁ ቪዲዮን እያቆማችሁ፣ ምክንያቱም ነው ኤክስፕሌን እያደረኩ ብዙ ጊዜ ላለመፍጀት። ሌላ ፎርጂንግ ማለት ምን ማለት እንደሆነ እዚህ ጋር ገልጫለሁ። ዲ ላይ ያለውን አንሰሩ ካስቲንግ ይሆናል። ስለዚህ casting is a manufacturing process where a molten material, typically a metal or alloy, is poured into a mold cavity and allowed to solidify, and this process is used to produce complex shape with intricate detail that may be difficult or expensive to achieve using other methods. So ይሄ የተጠየቅነው ጥያቄው ላይ ለጥያቄው መልስ የሚሆነው ካስቲንግ ኦፕሬሽን ይሆናል ማለት ነው። ሶ ካስቲንግ ስንሰራ የተለያዩ ፓተርን ክሬሽን አለ፣ ሞልድ ሜኪንግ ፕሮሰስ አለ፣ ሜልቲንግ ኤንድ ፑሪንግ ሜታል ፓርት አለ፣ ዜን ሶሊዲፊኬሽን ፕሮሰስ። እነኚህ ፕሮሰሶች ናቸው። ሌላ ፊኒሽንግ ፕሮሰስ አለ። ሶ እነኚህ ዱሪንግ ካስቲንግ ያሉ ኦር የምንጠቀመው ፕሮሰስ ኦር ስቴፖች ናቸው ማለት ነው። therefore here the method of manufacturing described in this the given question, which involves heating a metal or alloy above its melting point and pouring the liquid or metal or alloy or liquid metal or alloy into a cavity approximately of the same shape and size as the desired part is known as is casting. It is casting process. The next question, which one of the following describes the experimental result of tool life versus cutting speed for cast iron with different hardness, which is expressed in this figure? So ይሄንም ለመመለስ ምን ማለት ሌላ አናሊሲስ አያስፈልግም። እዚች ላይ ማየት ብቻ ነው የሚጠበቅብን ማለት ነው። የመጀመሪያ ምን ይላል? the tool life of given material decrease as the cutting speed increase. So here we have tool life at y and cutting speed at x. So the tool life of a given material decrease as the cutting speed increase. So እዚህ ጋር tool life assume ይሄ tool life ከሆነ cutting speed increase ባደረግን ቁጥር tool life እየቀነሰ ይመጣል ማለት ነው። ኤክስፐሪመንት ሾፕ ላይ ገብተን የሆነ ማሽን ራን ስናደርግም ሊሆን ይችላል። ስፒድ በጨመረን ቁጥር tool life እየቀነሰ tool የመሰበር ፕሮባቢሊቲ ለተለያየ ችግር የመጋጠም ፕሮባቢሊቲ ሃይ ነው። ስለዚህ ይሄ ትክክለኛው ነው ማለት ነው። the next, the rate of change of tool life is to speed, or the rate of change of tool life to speed for annealed material is high as compared with that of casted material. This is also right or correct because here we have 2 or 3 casted materials. እነኚህ ሶስቶቹ casted material ናቸው። ይሄ annealed material ነው። but እዚህ ጋር speed በጨመርን ቁጥር the annealed material ስፒድ እየጨመርን በሄድን ቁጥር ኦር እዚህ ጋር የቶል ላይፍ አለ ኦር እዚህ ጋር ደግሞ ስፒድ አለ። ሶ የዚህ ሬሽዮ ቱ this ratio to this when we compare with this one በጣም ሃይ ይሆናል ማለት ነው። ይሄ በጣም ሃይ ይሆናል። ትክክለኛው ምርጫ ነው። hardened cast iron tool life approach to 0 when the cutting speed is increased. This is obviously true also. So እዚህ ጋር hardened cast iron cutting speed በጨመረን ቁጥር tool life 0 ይሆናል። it is true because ከዚህ ይሄን ብናይ እዚህ ጋር ስፒድ በጨመረ ይሄ የዚህ ስፒድ ብንጨምር ይሄ ክሮስ ያደርጋል እዚህ ጋር ከስፒድ ላይኑ ጋር ይገናኛል። that means tool life 0 ይሆናል ማለት ነው። so this is true also. The correct answer is D, all are the true statement which shows this is the experimental result of tool life versus cutting speed for cast iron. So D is correct answer. Next one, which of the following graph illustrate the relation between torque versus speed and current versus torque of this shunt DC motor? So A this one, B this one, C this, D this one. So ይሄን ለመመለስ ሻንት ዲሲ ሞተር እንዴት እንደሚሰራ ማወቅ መቻል አለብን ማለት ነው። ሶ ሻንት ዲሲ ሞተር እንዴት እንደሚሰራ ካወቀን ሻንት ዲሲ ሞተር ቶርኪው ሃይ የሚሆነው የቱ ጋር ነው? ስፒድ ቶርኪው ሲጨምር ስፒድ ምን ይሆናል? ኦር ስፒድ ሲጨምር ቶርክ ምን ይሆናል? ካረንት ሲጨምር ቶርክ ምን ይሆናል? ኦር ቶርክን ሲጨምር ካረንት ምን ይሆናል? ሪሌሽንሺፓቸውን ማወቅ ነው። So let me discuss the relationship for this shunt DC motor. The torque versus speed graph of the motor is produce high torque at the low speed. That means when speed is near zero, at speed zero there is high torque, which is often referred to as this start torque, and as the speed increase the torque decrease. Speed እየጨመረ በሄደ ቁጥር ቶርኩ እየቀነሰ ይሄዳል ማለት ነው። But high torque ያለው at speed is equal to zero or at zero speed ላይ ማለት ነው። The curve typically follows a decreasing trend. ከርቡ decreasing trend ይከተላል ማለት ነው። ሶ ይሄን የሚያሳየው አሁን ከተሰጠው አማራጭ A ላይ ያለው ነው። ሌላው decreasing trend አይደለም። ሌላ high የሚሆነውም ደግሞ በዛ ልክ አይደለም። When we see this current versus torque graph in shunt DC motor, the torque produced is directly proportional to the armature current. That means torque እና current directly proportional ናቸው ማለት ነው። That means ቶርክ ሲጨምር ካረንት ይጨምራል፣ ካረንት ሲጨምር ቶርክ ይጨምራል። ሶ ይሄን ሌላ ደግሞ የነሱ ኢንክሪመንቱ ኦር ዲክሪመንቱ ሊኒየር ነው ኦር ሊኒየሪቲ የሚከተል ይሆናል ማለት ነው። ሶ ፍሮም the given with this explanation, the graph which shows this the torque versus speed and current versus torque for shunt DC is this is the graph shown at A. The graph shown at A. This C is correct answer. So thank you for this. አሁን ለዚህ አሁን ያዘጋጀሁት ቪዲዮ ይሄን ይመስል ነበር። ለሁላችሁም መልካም እድል እመኛለሁ። ፈተናውን ስትፈተኑ ግን አንድ ምክር መክራችኋለሁ። ፈተና ስትፈተኑ ፈተናውን በሶስት ቦታ ከፋፍላችሁ ነው የምትፈተኑት። ቀላል ጥያቄ፣ መካከለኛና ከባድ ጥያቄ። ቀላል ጥያቄ የምንላቸው እንዲሁ በቀላሉ አይተን የምንመልሳቸው፣ መካከለኛ የምንላቸው ደግሞ ቪዥዋላይዜሽን ክሪቲካል ቲንኪንግ የሚጠይቁ ጥያቄዎች መካከለኛ ላይ እንሰራለን። ስለ ካልኩሌሽን የሚጠይቁ ጥያቄዎችን ደግሞ መጨረሻ ላይ እንሰራለን። ታይም ማኔጅመንት ኦር ታይም ማኔጅ ለማድረግ ሌላ ምንም አይነት ጥያቄ ሳትመርጡ እንዳትልኩ፣ ሳብሚት እንዳታደርጉ። ምክንያቱም ጥያቄውን ሁሉንም ጥያቄ መስራታችሁን ምርጫ ማስቀመጣችሁን ማረጋገጥ መቻል አለባችሁ። መልካም እድል ይሁንላችሁ። ታንክ ዩ